So in this scenario, we're going to start off in a Jupyter notebook. We're going to pick up immediately after the process of training and validating that model. At this point, we have a model that's saved, and we're ready to go ahead and actually get that model into production. So the first thing I'm going to do is import my Wallaroo SDK along with any other libraries that I need. Wallaroo is installed software, so the instance itself is going to be installed in your cloud or on-prem environment, and this SDK will allow us to connect to that installation of Wallaroo and manipulate the models from our Python environment here. Next, I'm going to create a client to my Wallaroo instance. It'll prompt me to authenticate to that instance if I haven't done so recently, and then we'll open up that connection. Then I set my active workspace. Workspaces are a tool in Wallaroo to organize my models and pipeline deployments and control who has access to them. Now that I have a connection to my Wallaroo instance and I've chosen a workspace for this project, now I can go ahead and actually take my saved model and deploy it using Wallaroo. Deployment in Wallaroo really comes down to these three key pieces of code. First, I upload this model to my Wallaroo instance and essentially register it in my model registry. So I have my saved model file here, and I'm going to use the upload model function in order to accomplish this. I give the model a name, I specify the path to the saved model file, and I tell Wallaroo what framework this file is so that the Wallaroo instance knows what it's looking at. In this case, we're dealing with an Onyx file, so I use framework.onyx, but this could just as easily be any of the other usual suspects for Python frameworks. Things like XGBoost, scikit-learn, TensorFlow, PyTorch, Hugging Face are all acceptable inputs here. Once my model is uploaded, I can go ahead and move on to the second step, which is configuring the hardware I want to have available for this deployment. We create our deployment configuration, which is where I specify how many CPUs, GPUs, and how much memory I want to make available to this deployment. I can also specify the number of replicas here, which is essentially going to define how many of these instances of my model I have available to handle inferences simultaneously. I can set this to a static value, as it is here, or I can set this to auto-scale based on demand. In Wallaroo, all of these options are handled by the deployment configuration, which can be defined in a single line of code as we see here. This prevents me from having to manage the hardware myself using a tool like Kubernetes. Now I'm ready to combine the outputs of these last two steps in order to actually create my pipeline and deploy it. I give my pipeline a name. I add a model step with the reference to the model that I uploaded in the first step here. I call the deploy function with the reference to my deployment config, and at this point it will take a few seconds, and then my model is fully in production. Under the hood, Wallaroo has automated selecting the correct runtime based on my model, creating the entire pipeline and how data flows from one step to the next, configuring all of the necessary hardware and scaling parameters, and actually standing up a service in front of this. I can even call the URL function in order to actually display the URL that the service is hosted at, and I can send data to this endpoint and receive inference results back. Finally, I can test out this deployed pipeline using the SDK's Infer function. I use this to send a sample data point to my pipeline and examine the inference result returned. Now that we have this model in production using Wallaroo, we can shift our focus to all of the things that come after deployment in the machine learning operation lifecycle.